Näätänen is a psychological scientist, a pioneer in the field of cognitive neuroscience, known worldwide for the discovery of electrophysiological mismatch negativity. He was initially appointed Professor of General Psychology at the University of Helsinki. He then founded the Cognitive Brain Research Unit in the University of Helsinki, which he directed for 15 years. He is now Professor of Cognitive Neuroscience at the University of Tartu in Estonia and visiting Professor at the Center of Functional Integrative Neuroscience in Denmark. Risto Näätänen has received an impressive number of prestigious awards. He is member of the Finnish Academy of Science and Letters, Russian Academy of Science, and the Royal Swedish Academy of Science. In 2003, he wrote a book entitled Mismatch Negativity, a probe to auditory perception and cognition in basic and clinical research. The mismatch negativity provides a unique index of general brain plasticity. So we will now discuss mismatch negativity, a unique index of sound discrimination. Floor is yours.
Thank you, Professor Petit, for this very generous introduction. I'm going to present mismatch negativity in studies of sensory processing. So, mismatch negativity is a component of event-related potential, which can also be recorded with magnetoencephalography, and it can be recorded with PET and fMRI and many other methods, optical imaging. Okay, so this is very simple situation where auditory stimulus is repeated at 1 second intervals. And what we can see, these auditory responses are to the standard repetitive stimuli are like this N1, P2. This is at 100 and negativity at 100. This is about 200 positivity. Okay, and now, and this is passive situation, so subject is reading or doing something else. Okay, but if there is a deviant stimulus in this sequence, then there is an additional component here. It overlaps over a little bit N1 and it overlaps P2 also. And in difference waves you can get it visible so that it's like this, overlapping these after exogenous responses. So it's this area is mismatch negativity, and we can get it visible when we make this difference wave, subtracting standard stimulus response from deviant stimulus response. Okay, I don't go to this attent condition because there are many other responses overlapping. Okay, here in France, Marie-Hélène Giard and colleagues in Lyon showed the component structure of mismatch negativity. So if a sound changes, like some frequency change, for instance, what happens is that first there is activation is bilaterally in the auditory cortices. So this is negativity and this is the opposite positivity. So there are two dipoles here. But little bit later, maybe 20 milliseconds later, there is also frontal activation, which you can see here, and we have found that these represent pre-conscious detection of change, and when this change becomes consciously perceived, then this frontal activation is present. So it's a kind of attention switch from here to here. Okay. So I have developed a model sensory processing in audition. So if there is a stimulus here, then feature detectors analyze this stimulus, so like frequency, intensity, and so on detectors produce their output to some period which is called temporal window or integration. So all these outputs are integrated, and the result here in sensory is representation in sensory memory. Now it's first time everything is collected back, so all features are back. And now if, this event here usually elicits attention call, which is reflected by this frontal component of mismatch negativity, as you saw from Marie-Ellen's figure. Okay, and then this attention call mechanism is elicited, then there is an attention, then it means that kind of attention switch signal is sent to these conscious control mechanisms, and then these mechanisms look what is there now in sensory memory, and now it's conscious perception of what happened. And then we have all these events increase some excitability in transit detector systems. I forgot to mention that each stimulus, in addition to having these feature detector activations, then also activates transient detectors. It's like stimulus onsets activate these. And this is a second route to attention switch, so attention call caused by stimulus onsets, and this is reflected by an OR component. Okay. So how, in time, what this is illustrated like this. So we have here stimulus, then there is feature analysis, and this feature and temporal integration occurs here, and then this illustrates the emergence of stimulus representation, and perception is occurring about here, and then after stimulus is over, then this stimulus representation is present in echoic memory for some seconds. Okay, there are some interesting ways to use this response. For instance, in normal subjects, it was shown by Light and colleagues in California that by recording this mismatch negativity, we can predict the general cognitive ability. In this case, global assessment of functioning was reflected by mismatch negativity. So amplitudes go up, which means here in this figure down, then it means there is better performance in cognitive assessment of functioning. And this method has many clinical applications, for instance, measuring cognitive decline, which occurs in many kinds of brain disorders. But we don't go to them now. Canadian people, Houlihan and Stelmach, in I think Ottawa, they showed that mismatch negativity is higher with students with high, so-called high ability than with those with low ability in a kind of difficult perceptual task where subjects had to automatically detect this feature conjunction. If there was a mismatch deviance here, then this mismatch negativity was elicited. And all this happens automatically without any attention. Okay, here is nothing's. Okay, so now to the question. If there is a cognition and mismatch negativity relationship, then why is it so? And it seems that or it's pretty clear that what is reflected by attenuated mismatch negativity, it means that NMDA receptor is not functioning properly. So if this is not functioning properly, then mismatch negativity goes down, and it means that memory trace formation at all levels of memory go down. So if this is not functioning, then memory traces are not well developing, and therefore there is a cognitive decline because memory traces are the essential elements of cognitive activities, or what is represented by these traces. So conclusion is that mismatch negativity is a non-invasive index of NMDA receptor functioning, and therefore it has clinical significance. So if mismatch negativity goes down, it means that central auditory processing goes down, and then cognition goes down. Okay, so how do we know that the NMDA receptor functioning is reflected by mismatch negativity? There are many animal studies, in monkey, Javid and colleagues, in rat, Tikhon Radov, and mouse, Ehrlichman. So all these studies showed that if the animal gets NMDA receptor antagonist, most typically ketamine, then mismatch negativity goes down. Yeah, and the same has been shown in humans by Umbricht in Germany and Kreitzmann-Andermatt also in Germany. So here is one example of these studies. Umbricht had subjects measured with a brief psychiatric rating scale, which reflects how close a person is to some psychosis or psychotic problem. Now we can see if there are many psychotic responses in this brief psychiatric rating scale, then mismatch negativity is more responses, mismatch negativity is smaller. So there's very clear relationship that if mismatch negativity is small, then you are closer to psychosis somehow, or psychotic threshold. The same was shown also for duration deviance. I think this is my last slide. So mismatch negativity elicited by sensory cognitive violations at different levels of central auditory processing, and here we have all these different levels. So there are first simple sensory representations, and they elicit mismatch negativity, feature mismatch negativity, for instance, frequency change or duration change, and intensity change. They elicit this simple mismatch negativity. And now, interestingly, we can see mismatch negativities also for violations of complex sensory representations. For instance, in violations for parallel stimulus events or parallel feature stimulus events. So feature conjunction mismatch negativity, which is, for instance, that if your standards have certain frequency and certain intensity, and now if we and there are some other such connections in this sequence. And now if you switch so these features between two stimuli, so that high intensity, high frequency stimuli, which are standards, if they are, for instance, low frequency, high intensity, then there is a feature mismatch negativity. And the more important is this speech-sound mismatch negativity. So speech-sound is a composition of different kinds of sound element components, and if there is a change here, then there is very clear mismatch negativity. And then there are those violations of these complex of abstract rules, so that sequential rules, for instance, if one type of stimulus tends to precede another type of stimulus, so if you violate this, then you get rule violation mismatch negativity. And this is also happening with so-called syntactic mismatch negativity and phonotactic mismatch negativity. And then you can go one step higher to higher order representations, and when we get semantic mismatch negativity, so this means that if standards have a certain semantic meaning and deviants have another semantic meaning, then we get this mismatch negativity. And it's not because of physical changes, but it's because of changes of meaning. Okay, so that was my talk. I just mentioned a couple of things of this, some of the interesting perspectives. This measure can be used, for instance, in predicting psychosis onset in risk patients. It can also be used for predicting whether a person in coma state will wake up or die. This was shown first in Lyon, Catherine Fischer here in France. Fischer and colleagues, together with some people in Bristol, and then it can be used for predicting dyslexia in recordings from sleeping newborns. If they have attenuated mismatch negativity, then it means a higher risk to have dyslexia 7 years later at school age. And also, what we can monitor certain developments in some disorders. For instance, we can monitor the recovery from stroke. So at first there is no mismatch negativity, but then usually mismatch negativity comes back, and simultaneously discrimination abilities which were ruined by stroke, they come also back at the same time. And okay, I think these are the most important messages I can give. Also, with this multiple sclerosis disorder, and it has been shown here in France that small mismatch negativities means cognitive decline in these patients, but if the mismatch negativity comes back, then it means that cognition recovers. Okay, so I think this is all this time. Thank you very much.